Welcome to this tutorial on using Apache Cassandra with Java. In this session, we'll delve into the world of NoSQL databases, specifically focusing on Apache Cassandra. We'll cover everything from setup to executing queries. So, let's get started. First, let's briefly understand what Apache Cassandra is. It's a highly scalable NoSQL database designed to handle large amounts of data across many commodity servers. It's a great fit for applications that require high availability and scalability. Now, let's set up our environment. For this tutorial, you'll need Apache Cassandra installed on your machine. You can download it from the official Cassandra website, https://cassandra.apache.org/download. Follow the installation instructions suitable for your operating system. I'll wait a moment as you set that up. Next, we will need to include the Cassandra driver for Java in our project. If you are using Maven, you can add the following dependency to your pom.xml file. This driver will allow us to interact with our Cassandra database directly from Java. If you are not using Maven, you can download the driver.jar file directly from the Maven Central Repository, https://search.maven.org/artifacts/com.datastax.oss/java-driver-core. Make sure to include it in your project's build path. Once you have your environment set up, you can start your Cassandra server. Open your terminal and run the provided command. Make sure you navigate to the Cassandra installation directory before running it. To verify that Cassandra is running, you can use the CQL shell by typing CQLSH in another terminal window. CQL stands for Cassandra Query Language, which is similar to SQL. This will allow you to test Cassandra commands directly before we implement them in Java. Let's create a simple keyspace. Keyspace in Cassandra is a namespace that defines how data is replicated on the nodes. Run the following command in the CQL shell. After creating the keyspace, we can define a table for our application. For this example, let's create a users table that stores user information such as ID, name, and email. With our keyspace and table set up, let's move on to our Java application. We will create a new class named Cassandra Example. Start off by importing the necessary libraries in your Java file. Now, let's establish a connection to the Cassandra database. We will do this using the CQL session.builder method. Make sure to configure the session with the correct contact point, which defaults to localhost. Inside the try block, we will print out a confirmation message once we successfully connect to the Cassandra instance. Next, let's insert some data into our users table. We can use UUID for the user_ID to ensure that every user has a unique identifier. The above code creates a UUID for user_ID, then prepares a statement to insert user details into the users table. We execute the statement using session.execute. Now, let's retrieve the data we just inserted. We'll execute a select query to fetch the user information. In this code, we prepare a statement for the select command and execute it to fetch the results. We then iterate over the result set and print out each user's information. As a recap, we have successfully connected to our Cassandra database, created a keyspace and a table, inserted a record, and retrieved it. These steps provide a solid foundation for working with Cassandra and Java. Now, I'd like to show you how to handle exceptions that might occur while interacting with the database. It's vital for creating robust applications. Here's an example of how to catch errors during the connection process. You can handle various specific exceptions as well, allowing you to provide informative messages or take other actions, like retrying the connection. For instance, you might want to catch no host available exception to handle cases where Cassandra is not reachable. Another important aspect of using Cassandra is data modeling. Proper data modeling in Cassandra is critical because it influences how efficiently you can perform queries. Always design your schema based on how data will be queried, not how it will be stored. For instance, if queries often involve filtering by email, consider making it a primary key. Let's adjust our table to include email as a clustering column. This way, we facilitate efficient search based on email. Now, we can fetch user details by their email in a more efficient manner. We can likewise run an example to show how to use the clustering key in queries. By redesigning the data model based on how we want to retrieve the data, we can significantly improve performance. Next, let's explore how to update records. The above code modifies the entry in the user's table, updating the name for a given user_ID. It's crucial to understand that updating in Cassandra works differently from traditional RDBMS. Here, you essentially overwrite data. Now let's look into deleting records. Removing data in Cassandra is handled through the delete statement. We can run a command to delete a user based on their user ID. With the delete statement, we specify the user_ID to identify which entry to remove from the user's table. It's important to note that deletes in Cassandra are not immediate. They are marked with tombstones and removed in subsequent compaction. Throughout this tutorial, we have covered a wide range of concepts, from the initial setup to CRUD operations in Cassandra. Remember, mastering the data model is crucial for performance. Before we wrap up, let's discuss a brief overview of some additional features of Cassandra. It supports data replication, which is vital for high availability and fault tolerance. You can configure replication strategies based on your requirements. Another interesting feature of Cassandra is its ability to handle distributed data. It uses a peer-to-peer architecture, allowing data to be distributed across many nodes without a single point of failure. Lastly, make sure to explore advanced features such as secondary indexes, materialized views, and batch processing. These features can provide additional capabilities and flexibility depending on your application's needs. Thank you for joining this tutorial on using Apache Cassandra with Java. I hope you found it informative and helpful. Please ensure to subscribe for more tutorials and leave any comments or questions below. Happy coding!